Hi there! In the previous part, we amongst many other things looked at arrays. Arrays allow us to define types of variables that can hold several data items of the same kind. In this part of the tutorial, we will look at a data unit type that allows us to hold several data items of different kind. We will also look at one of the bases of modularization and reuse in software development called functions. We will look at how we can get data in and out of functions, and we will also look at the difference between passing parameters by value and by reference. We will finish this part by writing our very first function. First, let's look at a neat way to organize data. Suppose you wanted to implement an alarm and event system in your PLC software, so that you can trigger warnings, errors, information, or status messages. To keep track of these alarms and messages, you would need to have a data definition of such a message. One single event could, for example, have the following data. The event type, so for example alarm or message. Event severity, so in the case of an alarm, examples could be verbose, info, warning, error, or critical. Event identity, for example 3211. Event text, for example pressure loss in pneumatic cylinder. And a timestamp. Now assume we want to keep track of what has happened in our system over time. This would mean that we would need to store several instances of events. One way of implementing this would be to store this data in arrays. We could create several arrays, each one of them holding every piece of information, and every array being indexed from 1 to the amount that we want to be able to store, for example 100. This is not very user-friendly though. Although data might be declared this way, it might not be obvious that the data elements are related to each other. Just imagine if this data would be used at several places in the software. Then this definition would have to be updated on every single place in the software to be consistent. We also have 5 separate arrays to iterate over when we want to use the complete data for an event. Just as we can have arrays to hold data items of the same kind, we can use something called structures to structure data of different kinds. Structures is a user-defined data type available in the ISE standard that allows us to combine data items of different types. Structures are used to represent a record or logical group. If you want to achieve what we did in the previous slide of storing 100 records of events, we now only need to create one array of 100 instances of this struct. In this way, all data is now grouped into one single array instead of 5 arrays with different data types. To access a structured components, you use the following syntax. In other words, you write the name of the structure, a dot, and the component inside of the structure. In this example, we are accessing the event text and we are storing it in another string variable. To create a new structured data unit type, right-click on DUTs, select Add, select DUT. Enter the name of the DUT, in this case st_event, and make sure that structure is selected. This will create the struct so that we can fill the members of the struct. Just as with enumerations, the scope of structures is global, which means that all the code in your project will see the structure definition. You can't do like in, for example, C++ and create a local structure definition within a class. Now we look at functions, which are used to perform certain actions and they are important for using code. Define the code once and use it many times. Function consists of a function name, in this case Celsius to Fahrenheit. Don't be afraid of long function names. They should clearly describe their intent. Next, a function can have a return type. In this case, we want to handle floating point values such as 22.5 degrees, and thus we need to return a real or long real. Next, we have the inputs which will be used in the function, in this case a real value that we have named to F Celsius. Optionally, we might have some local variables in the function. The local variables in functions serves as our scratch pad, and this is where program variables are stored. To return a value, enter the name of the function and assign it the value to be returned. In this case, the input parameter F Celsius times 1.8 plus 32. Assume you have a program and we want to use this function. We need a variable to store a result, in this case the Fahrenheit variable. Next, we simply call the function and assign it the value that we want to convert to Fahrenheit. If we did this call with the value of 5 degrees Celsius, we'd get the value of 41 Fahrenheit. There are also ways to have more than one output value from a function. In this case, we have a function that takes in two numbers, n number 1 and n number 2, and returns the greater and smaller of the two. Note that the actual implementation of the function is very simple. We simply look whether n number 1 is greater than n number 2, and if so, assign n number 1 to n greater, and if not, we do it the other way around. To use a function like this, we first need to declare two variables in order for us to have somewhere to store the greater and smaller value. In this case, the two variables n return greater and n return smaller. Next, we call the function by its name greater underscore smaller, and we provide it with the two numbers we want to evaluate. Note the way to assign output values from a function to variables. Now the two variables will have the correct values. Functions can also have variables that are inputs and outputs at the same time. This means that we can both read and write from and to the same variable. These are declared with the var in out keyword. Let's assume we write a function swap_nums that swaps two numbers with each other. So in this case, we have two variables na with value 5 and nb with value 15, and we want to swap the variables with each other. If we provide these two numbers to the function, they will first go in as input parameters. Once in the function, we can write to the variables just like output parameters. To swap the numbers, we need to create a temporary variable called nNumberTemp and store the n_1 in it. Next, we store the value of n_2 in n_1. Finally, we can store the value of nNumberTemp in n_2. Now we have successfully swapped the values of the variables. To create a function in TwinCAT, right-click on POUs, select Add, and select POU. Write the name of the function and fill in the data type of the return value. Make sure that structured text is selected. This will create a shell for your function, and now you can fill in the implementation. When passing parameters into your function, you can do so either by value or by reference. Let's assume we have a function called changeColor, and it takes some sort of object as input parameter, in this case a colored circle. When you pass a parameter to a function by value, it means that the changes you make to that parameter inside the function will only be affected while inside that function. There will be no effect on the original data that is stored in the argument value. In essence, when you pass by value, you are sending a copy of the variable into the function. The copied variable can get changed inside of the function. However, the value of the original data will remain preserved. On the other hand, when you pass a parameter to a function by reference, the changes you make to that parameter inside the function will change the original data. When you pass by reference, you are passing the memory location of the variable to the function, and any changes you make inside a function will affect the location in memory and will therefore persist after the function completes. Let's look at some examples of how it could look like when we are passing parameters by value and by reference. Let's imagine we are writing a function, update event timestamp with system time, which takes our structure event that we previously defined as an input parameter and changes the date and time field of it to the current system time. In this example, we are providing the structure by value, and thus a copy is made internally in the function. To return a structure with a modified date and time value, we need to provide an output parameter, here called stEventOut. First, we would need to copy the complete content of the input parameter to the output parameter. And next we would set the timestamp of the output structure to the system time of the PLC. As you can see, this is quite inefficient as the input parameter ST_event is a copy of the original structure, and then we are making an additional copy by creating an output parameter. The equivalent function in C++ would be something like this. We can pass the value by reference instead, and then we are passing the memory location of the variable instead, so no copying is made. This can be achieved by either using the var in_out keyword for passing the parameter, or alternatively, provide the parameter as a reference to type that we discussed in the previous part of this tutorial. By providing the value as reference, we can write the date and time timestamp directly into the structure. The equivalent function in C++ would be something like this. I think it's really fun to compare structured text to other languages, such as C++. When should we use pass by value and when should we use pass by reference? By definition, pass by value means you are making a copy in memory of the parameter's value that is passed in, a copy of the contents of the actual parameter. The penalty for this can get quite extensive if the data that has to be copied is big. We can draw some rules, and to the rules there will sometimes be exceptions, but the three low-hanging fruits are 1. Pass by value when the function does not want to modify the parameter and the value is easy to copy, so for example integers, floats, booleans, etc. So by easy to copy I mean that the parameter is small, at most a few words. 2. Pass by reference when the function does not want to modify the parameter and the value is expensive to copy, so for example our structure event example. 3. Pass by reference when the function does want to modify the parameter and the value is expensive to copy. Now we have learned what structures and functions are good for. Let's now use our new knowledge to create something useful. Why not implement the function update event timestamp with system time, which will do exactly what the function name is called. That is, it will take our structure and fill the date and time value of the structure with the current system time of the PLC. Okay, so what I've done here is that I've created a completely new TWinCAT project, and I called it Time Project. And what we're gonna do in this project is this function that will take this structure, that defines the event. So it will take it in and it will fill the date and time value of that structure with the current system time of the PLC. Okay, so but before we create the function, we of course need to define this structure. So we create a DUT, select structure, and call it ST_event. I mean, this thing with ST in front of structures is just a naming convention that Beckhoff uses, but you can use whatever naming convention you want. I'm not going to enforce anything. The important thing, I think, is to just be consistent with your naming conventions. And let's create that. And now let's just fill the structure with the data that we previously talked about, the different data fields that we want in our event structure. So the first one we wanted was the event type, which just defines whether it's an alarm or a message. So it's of type event type. Now, yeah, this enumeration is not created, so we need to create that, but we already learned how to do that in the previous part of this tutorial. So let's create the enumeration, event type, and it can be either an alarm or message, like this. Save, close. Now we have that in the structure. The structure also needs to hold event severity. So this is basically, if it's an alarm, it will define whether it's a very critical error or less critical error, or yeah, there's different layers of this. And for this, we don't need to make up our own. There is actually one predefined in TWinCAT that's used for something that Beckhoff calls the event logger. So we're just going to reuse this one. I'm not going to talk too much about the event logger here, but there's basically already an application programming interface set up for creating events in the TWinCAT, in TWinCAT 3. And this This enumeration is called TC event. Yeah, there it is, TC event severity. We can actually check it out. And you see this one is also an enumeration, and you have, yeah, it's verbose, info, warning, error, or critical. So we have that as well. Next, we need some form of event identity, so just a number, and this of course can mean whatever. It's up to you to define what it is. If number 10 means pressure loss and number 20 means too high temperature or whatever, but we just need a unique identity to identify every type of event. And this can be just a number, so we'll do it an unsigned double integer. And next we need an event message or event text. I think we called it an event text, and this is just a string where we can write, yeah, too high pressure or yeah, just some message, whatever. We make it a string, and again, if you just write string like this, you can put 80 characters there, but let's just go with 255, which is a good size because that's the maximum size that a lot of built-in functions in Twinkle 3 can handle. Okay, and then we need the date and time. So we need the date and time of when this event was created. So we call this DT timestamp, and it's of type date and time. Time and time. That's not what I meant. Date and time. All right, so now we have our event. Next, we need to create our function. So what our function should do, let's create the function first. And to create our function, we go to POUs, add POU function, and we call it, what did we call it? Update event timestamp with system time, I think. And here again, you can have a naming convention. I usually call all my functions, start them with the F under. Wait, it's the UK. I need to change to Swedish keyboard. There we go. Yeah, I have a Swedish keyboard here. Sorry. F underscore update event time. So this is a naming convention where you just put an F in front of all the functions. Again, this is a naming convention that I've been using. You can use any naming convention you want. You don't need to have an F underscore. Actually, I just changed my mind. I'm not going to have an F underscore before that. We're just going to call the functions without any thing before. And the return type. This one, we're actually not going to have any return type, because this one is going to take the structure as it's going to be passed by reference. So the whole structure will be passed by reference, and we will write directly to that structure. So we're not going to have any return type, and we need a return type. Yeah, this is a silly thing. You always need to write a return type here. So you can just write blah 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 blah, and then you can just remove the return type afterwards. Very silly. Then, as an input, we need to have the event. So I just call it SD event, which is of type SD event, which we just defined, right? So if you look at this one, it's the structure that we just defined. So what we're going to do is we'll take this one in, and we take it in as a reference to. So we pass it by reference. If we didn't pass it by reference, why does it change that? If we didn't pass the reference as a reference, it would make a local copy here in the function, which we don't need. We just work with the structure directly. Okay, so we have a reference to this, and we want to update this timestamp with the current system time of the PLC. To do that, we will use our friend Google and check what existing functions exist already in TwinCat for this purpose. So Google and get system times TwinCat. This is basically what you do as a software developer mostly. You spend time on Google, Stack Overflow, forums, and unfortunately, with industrial automation, there isn't that much stuff on forums and on Stack Overflow or open source project. I mean, this is one of the problems. So you, in this case, you usually end up at Beckhoff's website, which is fine. All right. And here we have something, function block get system time. With this block, the operating system timestamp can be read. Okay, the timestamp is a 64-bit integer value with a precision of 100 nanoseconds. Okay, so this is a function block. I'm gonna go into what a function block is in the next episode of this part. For right now, we're only gonna use it. So we're not gonna care too much how this is working. We're just gonna use it. So to use a function block, we need to instantiate it. Okay, and you do that here in your local variables. You instantiate it in this way. So you create an instance of this function block. Again, I'm going to get back into this in the next part, so don't get too scared by this right now. And then if we call the function block, we get this time low dv and time high dv. It's just two parts of a timestamp. For some reason, Beckhoff decided to split it into two 32 bits values, but that's fine. So it just contains, it's 8 bytes for the whole timestamp. Now we need to store these values somewhere. So this only gives us the system time in some weird format. So we're probably gonna have to convert the system time into a date time. So hopefully there's going to be another function for this. So for right now, we'll just save these values into two local variables. So we just call it n low or n time low and n time high. Okay, and then okay, that's one output. That goes, this first output goes to this value, and then the time high dv goes to this one. Okay, now we need to look into some function to convert that into a dt. So what I usually do is, okay, let's go back to Google. Date and time, system time, Twinket, something like this. System time to dt, that sounds good. The system time, the input is some weird time struct, and it returns a date and time, but the time struct is not what we have. Okay, so let's go back to the system time to dt. That's not going to be good enough because it uses some weird structure and we don't have our system time in this particular format. So what we want is something else. dt to file time. I don't know. File time, what's this? Okay, this looks like something that we could use. It's a 64-bit value. So hopefully we have. Let's go back. So again, we're going to get back to this in a future part of how to look through all these libraries. But what we're looking at right now is actually different functions and function blocks of existing libraries, which you're going to use a lot in your software engineer career with Twinket software. So here we're just looking at everything. So wait here, file time to dt. Okay. So file time is what we have. It's two 32-bit values. And this can be converted to a date and time using the function file time to dt. Okay, so what we're going to do is that we're going to take this value we have that we get from system time, and we're going to store it inside a t, into this type t file time, which is a structure. Right? So let's create a structure of this instance instantiate it with this. So we're gonna create a t file time. I'm just gonna call it st file time. Okay, and here is the next problem. This structure, t file time, it exists in a library called utilities. And when you create a new project of TwinCat, you don't have that library included as a reference. So here we have references, and here you can add all the libraries that you have dependencies to. So normally you get the standard, system, and module. These are just the very, very basic stuff that you need. The very least you need in order to be able to compile a TwinCat program. But we need utilities. So what we're going to do is right-click on references, add library, search for utilities. There we go, TC2 utilities. Now we got file time to work. Now we can actually double-click on it or check. Yeah, you see, you have the structure, and the structure exists in TC2 utilities. So we have the structure, and now instead of using these two variables we created here, we can remove them. We don't need them because we're going to store the system time inside this structure. Because again, this structure is what we need in order to convert the file time to date and time, which is what we're using internally in our structure. So we remove these two guys, and we just used st file time dot low. So the low part of this get system time goes into our structure, this part of our structure, and then we'll go with the high date time. Okay, so by calling this, we'll get the system time from a function block that Beckhoff or someone else has already done for us. So we don't need to worry too much how this is working. I mean, we could look at the documentation for it and see what it does and everything, but we don't actually need to know exactly how it is working. We just need to know what this particular function block provides for us. And it provides a service, and we store the data that this function block provides into our file time structure. Next, we need to convert this file time into date and time. So, and this we do by using the function file time to date and time. So we'll call this guy, and it wants a file time, and we have a file time. That's our st file time. And this guy returns out is a date and time. Perfect, right? Because our date and time was what we had in our own internal structure, you see? So what we're gonna do is this parameter that we provided by reference, we're gonna store it in it. So we're gonna do st event dot date and time timestamp equals to the return value of this function. And that should be it. Clean it up a little bit. And now we can run this function and see whether we get what we want. So we're gonna create an instance of this structure. So this could be, of course, an array of events that you have in the system. You could have, as I described previously in the PowerPoints, that you could have an array of hundreds of events. Or just you could get an event from some other part of your system. You could have a special event handler of some sort. But for now, this simple example, we just create one single event, and we fill it with the data from this function. So we just create an event. This is our first instance of a structure. Okay, that was a very long name, which is an event. And then to fill it, we need to call our new function, update event timestamp with what I usually do. This is a trick that you will use a lot. I just start to write, and then I press Control space. magic. And then we provide the event. So st event equals this magical thing we just created. Now, what's going to happen is that this one is going to be called at every cycle, right? So this event will just get a new timestamp all the time. Maybe we don't want that. Maybe we just want it to be filled once. But so we'll do that. So we just create a very simple Boolean. That is bool. That's just going to be run once. So this is initially false. So if not, that is when this is false, run this one, then assign it to true. Which means that everything in here will just be run once, which is what we want. Okay? So again, we call the function that we just created. We provide the function with our event. The function takes the event as an input, but the input is passed as a reference to, so no copying is done. It's just provided into the function, a reference to it into the function, and then we use a backoff function, get system time, to get the system time of the PLC. We store the output of this function or this function block into a structure called tFileTime, and then we get it into this format of tFileTime. Then we need to convert it to date and time, which we do with filetime to dt. And then we store the value in the timestamp of our structure. Easy peasy, right? So let's build this, compile. Okay. So let's see. Okay, so now if I start this one, it will just be executed once. And so let's run it. Yeah, there we go. And the timestamp was filled with the, yeah, it's the right time. Okay, so that's the time is probably in UTC or something like this, but we got the system time anyway of the system. So it worked. You might have noticed that there was a lot of stuff happening here, and this is usually what happens when you develop software, right? You don't quite know how to solve the problem, but that's the nice thing. I mean, this is one of the things I love with writing software. You just don't, you know where you want to get to. You have a vision, you have a picture in your head of where you want to get to, but you don't know how. But that's what's so fun. That's the absolute best thing with software development is the learning process. To just go around, look for information, do some thinking, and solve the problem. And then it's just a very enjoyable feeling once you get stuff to work. And again, you never have all the answers in advance, and that's the great thing with this. It's just a constant discovery. This was a very simple example, but you'll quickly see once you get to work with real projects, the complexity is just gonna skyrocket, and things are gonna get really interesting. Yeah. That's it for this part. We managed to create our first structure and a function that's actually quite useful. In the next episode, we will look at one of the building blocks of object-oriented programming, the function block. See you in the next part.